Well, good afternoon and welcome. I am Erin Reed, and I'm a marketing consultant working with Polaris MEP. Polaris MEP is a nonprofit consultancy dedicated to helping Rhode Island manufacturers grow. We are part of the NIST National Network of Manufacturing Extension Partnerships. And today we're very excited to present our very first Polaris MEP online learning event. Yes, it's our very first. We have pivoted from our popular in-person lunch and learns to digital events. And now that pivot is something I know you're all doing daily in your personal and professional lives. So I'm going to, Josh, pause on this slide here so we can talk about what that pivot means to this specific application, the Blue Jeans app, because we want to make sure that you can actively participate in today's webinar, just as you actively participated in our in-person events. So this is the Blue Jeans control panel. If you glide your cursor across the screen, it comes up, and it allows you to send questions or comments to us. So number one is the basic kind of material controls where you would mute or unmute to talk. As I mentioned, we have muted everyone to make it a little easier to hear Josh, our presenter. But if you need to leave the webinar, please use the red kind of phone icon there. Number two shows where the chat button is. If you click on the chat button, you can share a thought, respond to a query, or again, send me a note for troubleshooting. So let's go ahead and give it a whirl. If you all can use your chat button and let us know you're here, that would be great. You can tell us your name, say hi, whatever feels comfortable to you. But let's make sure you guys all have access to that chat so that we can participate in polls and questions and answers. Hi, Tom. Tom Connell is here. Excellent. We've got more folks logging in. This is terrific. Thank you all for letting me know that you can hear us and communicate back. The last little point of housekeeping is we are recording this webinar. We're doing that for two reasons. Number one is that we want to make sure that we are giving you guys our best efforts. So you're a little bit of a guinea pig today and we'll be learning. Secondly, we want to make sure that you can really absorb what Josh has to say. So we'll be making this video recording available on YouTube after the event. All right, so Josh, if you could advance one more slide now that we've got our roll call done. As I said, this is our first online learning event, and we knew we'd be in good hands because Josh is such a pro and because his topic today is, quite frankly, about learning with internet-enabled processes and machines. Now, Josh himself has frequently pivoted in his career. He's taken on new industries, such as medical devices and aerospace, and many new projects, and he's one of Polaris MEP's partners. We value him for his years of manufacturing leadership and his way of cutting through buzzwords and trends to figure out what will actually improve business and operations. So this brings us to today's topic, the Internet of Things, because prior to our coronavirus situation, the Rhode Island manufacturing industry had shared with Polaris MEP that their top priorities included cost reduction and supply chain management. And so these are two areas that we know can benefit from the Internet of Things. How they do that, well, that's up to Josh. Josh, take it away, please.
Thank you, Erin, and thank you to Polaris MEP for sponsoring this webinar. I want to extend my best wishes to everyone also. I hope everyone is safe and healthy and doing their best to maintain sanity at this difficult time. Here's today's agenda. We're going to talk about what Internet of Things is, how it's used, a little bit about how it works. We're not going to get real technical, and how to get started. By way of introduction, I'm one of 4 partners at Business Improvement Group. All of us have run manufacturing companies and manufacturing plants. We've worked in 22 industries on 4 continents. And we are very happy to be a partner of Polaris MEP. We've worked with several Rhode Island companies already. And my contact information is down below. Incidentally, everyone on this call will receive the deck from Aaron after the webinar is over. And in a week or two, it'll be posted also on YouTube. So just try to relax and enjoy this thing. There's a lot of slides. We're going to move pretty quickly. Don't try to take a lot of notes. Just try to get the flavor of the thing. And then if you want the commentary later on, you can get that from YouTube. So what is this thing? Well, first of all, it's called at least 3 different things. Internet of Things. IIoT means Industrial Internet of Things. And Industry 4.0 is another term that simply means the same thing. It's just a different term. It originated in Germany. The Industrial Internet of Things is a subset of Internet of Things. It simply means applied to industry, applied to factories and plants and products. The classic definition is things communicating with things over the internet, providing either information or instructions. And Waze is a good example. Once you turn the app on, you don't have to do anything. It does everything for you. It gathers whatever information it needs to. It communicates with other folks in your area. It'll send the information up to a satellite and back down, and it'll tell you exactly where to go, and there's no human interaction at all once you turn the app on. Here's a second definition, and I like it better. It's a little wider. The automated gathering and analysis of information to do useful tasks. And you'll notice that it doesn't have to involve the internet. As an example, you can gather information from a machine on the floor of your plant and send it to a database or to your server or wherever, and none of it has to involve the internet at all. But it's doing exactly what IoT does. It's gathering information and perhaps analyzing it automatically. So I like this definition better, and I've actually done a lot of stuff that does not involve the internet at all. There's a lot of benefits to Internet of Things, and rather than recite the list, I'm going to tell you a story. Many years ago, I met with the president of a customer, and he was telling me about an effort to reduce inventory, and I asked him how he was doing it. And he said, well, we've tuned up our MRP system. We're using that better. We're using some RFID tags. We're getting better at bin locations. We're looking into our customer systems to anticipate orders. We're looking into our suppliers to see if they can ship. And then he kind of leaned back and said, you know what we're really doing here? We're replacing inventory with information. And that phrase, replacing inventory with information, hit me like a 2x4, because it was the very first time that someone had put into words the power of information systems to make things happen and to make them happen better. And that was when I got religion about information systems and information flows in manufacturing. I'll bet most of you are doing it already. And we'll see soon enough. Erin is going to take us through a little poll.
I am. So here's what we'd like you to do. Using your chat function, can you tell us, yes or no, is your company doing any of the things listed on the screen? Now, I know we also have some consultants on the line with us today. So think about your clients. Are any of your clients doing any of these things? Yes, if they're doing at least one of them. No, if they're not yet using any of these tactics to gather that information. A wide variety of options. Automated gathering of data from the floor, roll charts, automated alerts. So is your company, or if you're a consultant, one of your clients, doing all of this? All right, the information is coming in for us here. This is great. If you're currently starting a project, we think they could count as a yes as well, right? Ooh, and thank you very much, Dan, for telling us which ones that you have kind of experience with and have underway. That's fantastic. I appreciate that several of you have said, yes, you're using some of these tactics, but no, not so much with others. All right, we'll give you one more second to get those in there, and then we'll count up what our total is. Right, I think we've heard from about half of you.
So, Aaron, what percentage are doing at least one of these things?
All right, Josh, so we have 62% of our attendees today are doing at least one of these things. That's 62%.
Okay, and that's pretty much what I expected. A lot of companies are doing stuff that actually is thought of as Internet of Things already, but you're probably not calling it Internet of Things. And that's really interesting. So that's good. Thank you. Okay, let's talk about a few of the uses. We're going to move pretty quickly through these slides. Business to consumer applications, for instance, a washing machine. What could a washing machine do? Well, if you're running a load, it could search the grid and tell you what time electricity will be cheapest and ask you if you want to run your load then. Or perhaps the manufacturer could look at how the machine is running and tell you that a certain part is about to fail before you even know it, so it doesn't fail at an inopportune time. A B2B example, doctor blades. Doctor blades are scrapers on rollers. They keep rollers clean. They're used a lot in the printing industry, in paper making industry, in any kind of industry where there's rollers. Doctor blades wear over time. When they wear, they chatter. You can install a sensor on a doctor blade and know ahead of time when to replace it. Another example, this is an interesting one. When General Electric sells a locomotive, they also sell a package of sensors, analytical software, cloud storage, as well as service and maintenance and spare parts. Value of that package is roughly 16% of the upfront cost of the locomotive. In other words, when they sell you a locomotive, in another 6 years or so, you're buying a second locomotive. But instead of being a one-off transaction where you buy your locomotive and that's the end of it, this creates an ongoing revenue stream, almost like an annuity for General Electric. And that phenomenon is called products as a service. Some other uses, logistics tracking, temperature sensors to make sure that your meat stays cold as it's transported around. Remote machine diagnostics. This is an old one. It predates Internet of Things. It's been around forever. Asset management. Where are my machines? How many of them are there? How many are running? How much are we utilizing our machines? Or for inventory. How many of this SKU or that one do I have? Where is it located? Autonomous vehicles, you've all heard about those. That's another application. Smart cities. As an example, there are several cities that have outfitted their garbage trucks with cameras underneath that are trained to recognize potholes. And when they see a pothole, they send an automated message to the DPW that says, 100 feet west of 4th Street on Smith Street, there's a pothole. Come fix it. Agriculture. They're using drones now, outfitted with infrared cameras that are really good at telling the health of a plant. And when the drone finds a plant that isn't so healthy, it can send an automated signal to a drip irrigation system that will feed that plant and that plant only. So it's very, very green and very cost effective. Supply chains, not only the supply chains that you think of, customers and suppliers and their suppliers and so forth, but things like vending machines. Pepsi and Grainger both put the vending machines in plants, and now they can tell exactly how empty they are and what products they need to restock. Augmented reality. This is a big one for manufacturers. For those of you who are new to that, it refers to imposing an image, a virtual reality, on top of a real reality. So here you see a woman who's working, looks like in an auto plant, and she's wearing some special glasses that superimpose a diagram on top of the reality, so that she knows exactly what's going on or what button to push, or she can do diagnostics or whatever she needs to do. Internet of Things is making new business models possible, and one of them we just talked about. Products as a service, the example of General Electric turning a one-time sale into an ongoing annual annuity. Automated supplier monitoring, like Pepsi and Grainger, but also services like the doctor blade. The customer notices chattering in a doctor blade. What do? They call up the manufacturer of the doctor blade and say, send me another one. Running whole supply chains. And another issue that we'll talk about a little later has to do with generating data. Data is really valuable, as Google and Facebook will tell you. It's just as valuable for manufacturers. We'll talk about that again in a few minutes. I'm not going to spend a lot of time on this slide, but it's worth noting. This is a slide from a McKinsey report, and I think they stole it from Bain. I'm not sure. But it shows 8 different ways that Internet of Things can generate value, depending on what your business is and where you are in the supply chain. It can do with process improvements, asset utilization, labor productivity, inventory quality, service and after sales, and there are others also. And the point is that it unleashes the ability to think creatively about how to use this stuff, depending on what your business's strategy is. Within factories, BMW has a factory in Germany that gathers data from 3,000 machines, robots, and automatic guided vehicles in one factory. You can imagine the amount of data that produces and what they can do with it. Practically any question they could want to answer is resident in that data somewhere. Another one that we're going to talk about later, and this is really important, is driving decision-making down, making data and information actionable to your people on the floor, which frees you up to do other things. And augmented reality, which we just talked about. These are real things. They are happening right now. So we're going to talk about kind of building the model, and we're going to start at the bottom. And this is probably the most important slide in the whole presentation. Start with the end in mind. Okay, don't start with the technology. Ask yourself these kinds of questions. What am I trying to accomplish here? What am I trying to learn? What's important for my business? And the most important one is probably the last one. What is important for my business? If you think about your business's strategy, you think about the main tactical goals that you want to achieve this year to support that strategy, and then bring it down into, okay, what do I need to do in my factory? What do I need to learn? This is the most important step. It's also the most difficult step. Don't worry about the technology. The technology exists to do whatever you can imagine. But you should spend a lot of time on this. So if there's one message that I would like you to take away from this webinar, this is it. Okay. At the very bottom, once you've decided what you want to do, are ways to gather the data. And there's three primary ways. There are others also. The one you hear the most about are sensors. And pictured here are four of them. Going left to right is a thermocouple, a vibration sensor, a pressure sensor, and an acoustic sensor. And you can see they're pretty simple and they're pretty cheap. Depending on how fancy you want to get, you can get them for, in some cases, between $10 and $50. It's pretty short dollars, and there's a huge variety of them. A second place that you can get a lot of data is right off your machines. Right in your PLC, your programmable linear controller. And if your machine is, let's say, no more than 10 or 15 years old, it'll probably have data tags, which are really just localized controllers. They enable you to pick up one piece of data at one part of the machine. So for instance, in a printing press, to measure revolutions, there will be an encoder on the printing cylinder. And you can pick up the data right from the encoder instead of going through the PLC. Another place you can build data is RFIDs, and usually that's used for locational data. Where is this asset, or where is this piece of inventory? So this is where you gather all the raw data. You haven't done anything to it yet. You simply gather it. A little bit of a sidebar here about sensors. How are they used? And here's two examples. You could put a temperature sensor and a vibration sensor on a bearing. Why would that be interesting? Well, if you track the temperature and the vibration over time, it'll bob along and bob along and bob along, and then at some point it will begin to trend upward. Now, why would that be? Well, probably there's a little chip in that bearing, or it's slightly out of round, or it's been ground down. And that will cause vibration, and vibration causes heat. And that will tell you that the bearing is beginning to fail. And isn't that nice to know that ahead of time so that you can replace that bearing at a time that's convenient for you, like maybe during a setup, than when the thing just blows in the middle of a run. And of course, it'll be the run that you're doing for your hottest customer who had to have that shipment out at 5 o'clock in the afternoon. Guarantee it. So this is a wonderful way of getting ahead of maintenance and turning preventive maintenance into predictive maintenance. Another really neat example is in Australia. They built a steam plant. Turns out that when a steam plant is running efficiently, the steam makes a certain pitch as it whistles through the pipes. And that pitch is like a fingerprint. It identifies that the thing is running efficiently. And that fingerprint will change if conditions deteriorate. For instance, there might be condensation on the inside of the pipes. There might be a little oil buildup. There might be dirt. There might be a trap that's full. And each of those have their own fingerprint counts. And with enough data over enough time, you can identify those sounds and you can identify the locations. And instead of having people running all over the place listening to stuff or looking at dials, you can simply send them to where they're needed and have them clean out the trap or whatever needs to be done. And this plant in Australia has over 50,000 acoustic sensors in one plant. Okay, so now you have all this data. It's a big pile of data. By itself, it's kind of useless. The next thing you have to do is organize it. And that's generally done with a database. You all know what databases are. They're simply ways of organizing that raw data. And then the fun begins. And here's the fun. This is where the humans have to start thinking. You have to do analysis on that data to turn it into something useful. And there's generally two categories of doing that. The first one has to do with answers that are already in the data. For instance, your shift productivity. You're going to have one heading that says shift 1, shift 2, shift 3. You'll have another heading that says we produced 40,000 widgets or 35,000 widgets or whatever. And if you want to know which is your most productive shift, that data is already there. You don't have to do anything for it. All you have to do is organize it in some way to get the answer. And usually databases come integrated with report writers or what's called BI software, business intelligence, such as Crystal Reports. And so what you do is it's really easy. These things are really easy to use. Typically, you drag headers. So you would drag your shift header up, you would drag your productivity header up, and you would push a button, and you would get a report. And shift 1 is the best or the worst or whatever. But the point is, it's really easy to do. The capability is already built into most of the databases, and the answers are already in the data. The second kind has to do with where data manipulation is required. In other words, it's going to use the same data in the database, but it has to be manipulated in some way to get the answer. And that usually involves using some kind of a statistical program like Minitab is a very popular one. So to answer a question like, what is the relationship between tension and waste, you have to do some manipulation. You have the tension data, you have the waste data. What you don't know is how does one cause the other. So you run a statistical correlation or regression or whatever it is that you do, and it'll tell you that the optimal tension is, let's say, 20 pounds per linear inch or something like that. The only difference between these two is one is in the data and one has to require data manipulation. The common thread to both of them is that it's humans doing the thinking. And if that becomes too complicated, and sometimes it does, you then go to what's called artificial intelligence. And I won't get into a philosophical discussion about what intelligence is. But to me, as a manufacturing guy, it's just a giant statistics machine. And it does exactly the same thing as we talked about on the previous slide. It just automates the thing. It will automatically look for relationships. It will look for trend lines. It will ask questions that you might not have thought of. It can learn over time. It can predict the effects of changes. But it's really exactly the same thing automated. And that's really all artificial intelligence is. The last step, if you choose to go that far, and you don't have to, is a thing called the digital twin. The digital twin is simply a numbers-based virtual representation of a single machine. And by single machine, I mean right down to the serial number. So if you bought 5 machines, same make, same model, they were installed the same day, they are each going to have their own digital twin. And why would that matter? This is why it matters. You see a picture here of 3 compressors. I probably should have made it 2. So let's think of 2 compressors to make it simpler. Are they really identical? Well, on day 1, they're pretty close to identical, but no 2 machines are perfectly identical. Those 2 machines will perform very slightly differently beginning day 1. And over time, the performance will begin to diverge. And it may diverge for either of 2 reasons. One is that one of the machine was made slightly differently from the other, but the other reason that's more likely is that the machines are used differently. And I chose this example for a reason. In most plants with 2 compressors, there's a lead compressor and a lag compressor. The lag is sort of the backup. And the lead compressor will run 80% of the time. So over time, you would expect it to perform differently than the lag compressor. It's being used 4 times as much. So let's say you do some maintenance. Let's say you change a filter. Well, your digital twin will immediately grab the data from the database and it will record that difference, and you'll be able to see that difference. But here's where it really gets interesting. You could ask the question, if I change that same filter on the lag compressor, is it worth it? Will it make enough of a difference? And it will be able to tell you, well, it'll improve performance by 7%, it'll reduce your electrical load by 7%, and therefore your costs will go down by X dollars. And you can compare that against the cost of changing the filter and decide whether it makes sense to do it or not. So these things are used as simulators almost. You simulate changes before you actually make the physical changes, and you can predict what the effects will be. Now we're going to put it all together. This is a summary slide. Again, you start with, what am I trying to accomplish here? That's where you have to start. It doesn't matter what you're trying to accomplish. You don't go out and buy a car before you decide you need to buy a car. So understand what it is you're trying to learn and make sure it's actionable. Then you go to the level of collecting the data. You put that data in some kind of an organized format, like a database. The humans start thinking about it. They start querying the database or doing statistical analyses. When that gets too complicated, you bring in the machine learning to do it on an automated basis. And when you have enough data, you can now, if you want, start using digital twins. Now, not all of you are going to need to do all of this. And in particular, the AI level and the digital twins are not appropriate for a lot of small plants right now. It'll complicate things. They need quite a lot of data to be effective. But certainly the first 4 steps are within the realm of possibility easily. They have tremendous benefit. And then later on, if you want, you can add the AI and the digital twin. So this is a progression that you follow over time, starting at the bottom. Okay, Erin.
Yeah, Josh, that's a lot of great information. Thank you so much. So let's take a little moment and kind of address some of the questions and comments that have been coming in. So Nathan made a great point. Actually, he was complimenting you for your great point, Josh. And that was the idea of variation is the enemy. Can you speak a little bit to how some of these industrial Internet of Things can really pinpoint. Do you have any examples of how an IoT kind of solution helped focus and bring to light some variation?
Yes. Process variation, as anyone with a Lean or Six Sigma background will tell you, is the root of all evil. Here's a good example. A client of mine is, among other things, a printer. And there was way too much variation in the quality of the printing. And in those situations, what the operators do is they tend to push too many buttons at the same time with the best of intentions, but they don't learn anything. They're simply kind of randomly trying to figure out what's going on. And so what we did was we installed a bunch of sensors at different places all along the kind of the chain of custody of the ink. For instance, we measured viscosity right at the receiving dock, so that we knew what kind of viscosity we had. We measured pH. We measured a number of different things in the ink themselves. And then when the inks were presented to the machines, we also measured viscosity. We had that sensor linked to an automatic feed of some thinner in case the ink was getting too thick. Automatic injection of either acids or bases depending on what the pH was. And we also measured laydown, and that got pretty complicated, so I won't go into that. But the point of the thing is that the startup waste on the machine, the amount of time it took to achieve what they call good print, good fidelity to the original proof, went down by more than 50%. And so did the waste. What else do we have, Aaron? Aaron?
Yep. So that's a great savings there and a great example. Thank you, Josh. So another question that has come in is that when you said putting it all together, one of the first steps would be things like sensors and PLCs and tags. So the question that was there was, could one of my clients have sensors in their factory that they don't know about and so I don't know about? How do we find out what's already there when it comes to sensors?
Yeah, that's a great question because you don't want to reinvent the wheel. You almost have to do an audit, machine by machine, because machines are of different ages and they'll have different capabilities. They'll probably all have PLCs. They may or may not have data tags. They probably will not have sensors, although a few might. And then you want to audit things like fork trucks and your inventory bins if you're using RFID tags and so forth. And that's really important to understand where you are as a starting point. But that's really the only good way to do it is to do an audit of your factory.
Excellent.
Okay.
So one other quick comment was that one of our folks said, you really need a process map. Can you talk to how long would it take? Is that process map part of the what am I trying to accomplish step?
Yes, it is. It's probably the second half of that. You might want to ask a question like, let's go back to the other example. Why is my print so lousy? That's a good question to ask. And in fact, a process map is the second thing we did. We tracked the ink through the entire chain of custody. And we asked the question, what do we know about this ink at each step? And the answer was not much, which is why we installed the sensors. But that's a great question. And it certainly has its place, the process mapping, because that will help you decide at what stage you need to gather what kind of information.
Excellent. Thank you all for these great questions and comments. And Josh, we've got another section to go to help us figure out how to tie this all together, right?
That's right. Couple of sections. A few cautionary notes. One is that Internet of Things in factories is currently probably better at discrete manufacturing processes than continuous processes. Oddly enough, I just gave you an example of a continuous process, printing, in which we put IoT to work. But nonetheless, there are more applications developed for discrete manufacturing processes. For instance, machine shops. Machine shops are adopting this stuff at a very rapid rate because it's very easy to do. And there are a number of companies out there that specialize in it. But I don't want to discourage people who have a continuous process because it's quite doable. It's just a little more difficult. And the printing example and also the steam plant example are good examples of continuous processes. A second one has to do with cybersecurity, and this is really important. Sensors they don't come loaded with McAfee or Norton. They're just stupid, dumb, naked little devices. And if they're not behind the firewall, they are very vulnerable to hacking. In fact, that is the most popular way for hackers to get in. So whatever you do, put your sensors behind the gateway or behind the firewall and make sure they're protected. And I'll take this opportunity to mention that Polaris has excellent resources to help you understand and implement cybersecurity, particularly in the defense business. The Defense Department is requiring that all suppliers, whether you're Tier 1 or Tier 10, get in line with a number of the DFAR regulations. It's really not as bad as it sounds, but it can be confusing. And so I would direct you to Polaris. They have excellent people there and excellent resources to help you figure that out. And here's a story that my son passed on to me of using sensors to hack something. This was a casino in Las Vegas. They had a huge fish tank. They had a bunch of sensors in there that measured the temperature and the pH and the salinity of the water. And it was all connected to an automated system that kept the water whatever way the fish liked it. But those sensors were not behind the firewall. And they got hacked by someone in Finland who grabbed all the data that the casino had and held it hostage for $1 million in Bitcoin. So if you don't believe me about keeping your sensors protected, believe me, it happens to the best of us. Here's an interesting question. Who owns the data? Data is valuable. As I mentioned, Google and Facebook, they understand this. And there is no one answer here who should own the data or how valuable it is. It'll depend on your business. But the point is to pay attention to this question and negotiate where it's appropriate. And a couple of examples down below. The Dr. Blade manufacturer didn't want the data at all. They didn't want to be responsible for it. They didn't want privacy issues. They didn't want the cost of storage. They didn't want any of it. They said, let the customer have it. When those Dr. Blades begin to wear down, they'll call us up and get a new one, and that'll be the end of the story. But GE and the railroads share their data, and they both own it. The railroads have an obvious interest in it. Why would GE? Well, for one thing, they can learn a lot about their customers with that data. Who's utilizing the locomotives the most? Are they going uphill or downhill or flat? Good weather or bad? How many cars are they hauling? How much weight? So they can learn about how their customers use the product and presumably build features in later on that meet customer needs. It also helps them understand about the quality of their own product. If they find that bearing number 547 is always burning out before all the others, they can then go back into their manufacturing process and say, okay, what's going on here? Because we got a problem. Design. if any of you are designing products that need these kinds of interaction capabilities, or let's say they're going to hook up to your Echo or your Alexa or whatever it is, build that in up front. Build that into your design initially. Don't try to do it afterwards. This is another really important one. Training your frontline personnel and being able to delegate decision making. If you take a look at that little chart in the middle of the slide there, I have no idea what it means, and neither do you, but I'll bet that the machine operator does. He can tell you what's going on here and whether it's good or whether it's bad. If they have the skills to interpret data, and that is a big, big if. I highly recommend that you train your people in basic statistical techniques. Don't get fancy, but the basics of understanding averages and trends and how to interpret control charts and things like that. Because that will make the information actionable. You want them to be able to do something with this data, not just look at it. And in the best of all possible worlds, you'll be able to delegate a lot more responsibility to your frontline personnel, and that in turn will free you up to do things that are useful to you. So, a little bit of summary here. Start again with the end in mind. What are we trying to do here? I highly recommend visiting other companies who are doing it already. You'll learn a real lot. Understand your current capabilities. This goes to the question that was asked a couple minutes ago. Understand where you're getting data right now and where you're not taking advantage of where you could be getting data. You know, do you have data tags on your machines or not? So do that audit. And then begin to design your system. And when I say design, I mean literally with a paper and pencil. Map it out, iterate it. It will change over time. And this is the point at which you might want to engage your PLC manufacturers in that discussion, because those companies live in the world of data. They really understand this stuff. Make sure there's a business case. There are benefits and there are costs. You've all done ROI. Make sure there is one. Don't do it because IoT is the next shiny object. Do it because it improves your business. And then you can find the technology to do it. And I guarantee you, I absolutely guarantee you that no matter what you think of, the technology is out there to do it. Don't worry about that. And then they also recommend choosing a small starting point as a model, a single machine perhaps, or a group of machines. Learn from that and then proceed across the rest of your factory. Don't do it all at once. It's too much. Little bit of technology stuff. Some of the questions I get asked most frequently. Should I do it on a server or in the cloud? And the answer is increasingly the cloud. Your server won't have enough memory. It doesn't have any of the integrated services that the cloud stacks do. The cloud is cheap, the security is better, and it will integrate all this stuff, the database, the analytical tools, the stats platform, your AI, visualization and augmented reality if you want that. Device management platforms are the things that will automatically pull your sensors behind the gateway. That's a cybersecurity issue. A lot of that stuff is built in, and various alerts. So I highly recommend going to the cloud. Do you need 5G? The answer is no. I'll just leave it at that. Unless you're a meteorologist or you're running autonomous vehicles, the answer is no. Plenty of companies are doing this on 4G already, and that's plenty. A little bit about standards. Each of the stacks that are operated by Microsoft, Amazon, PTC, and some others have their own storage, their own analytics, their own augmented reality, and all that stuff. And they're all interoperable. So if you go with a single stack, it will work all together. Just as a note of interest, Amazon, Apple, and Google are working on standards for their home devices, but those standards have to do with connections and communication, not the feature. And this doesn't mean anything to you unless you're a manufacturer of some kind of a product that integrates with these devices. And you should know that they're working on standards so that if you design your device for an Echo, for example, eventually it'll work on the others as well. A bigger challenge is if you have multiple PLC manufacturers in your plant. If some of your machines are running on Allen Bradley and some are running on Siemens, you have to find a way to map the data coming from those different devices into your database. It's not impossible by any means. It's relatively easy to do, but it makes things a bit more complicated if you have multiple PLCs within the same factory. And finally, the question that you're all asking, and there's the answer. It's a big red question mark, because the cost of this thing really depends on how much of it you want. The size of the installation, the number of machines, what kind of data are you collecting, whether you have an existing relationship with a cloud provider already, and how many other services you want. Another one is that third bullet. As an example, there are thermocouples that will gather data on temperature 1,000 times a second. That's appropriate for some people, but not for others. There are plenty of applications where gathering data once a second or once a minute or even once an hour will be plenty. So don't get more data than you need, because you're just going to have to pay for more storage, and the analytics are going to be more complicated and stuff like that. So get only what you need. I will say this. If you're starting with nothing, if you have no current cloud memory at all and no sensor, nothing, you can get going with your first little group of machines, sensors, database, your cloud memory, and all the other stuff you need for a few $100s a month. It won't break the bank. And the next group of machines that you add will cost less than the first, because a lot of that stuff is already in place. So you can do this for a pretty reasonable cost. On the other hand, if you're BMW and you're gathering data from 3,000 machines and you're doing all kinds of virtual reality, I mean, I have no idea what their budget is, but I'll tell you, it's bigger than mine. So the answer is it depends. And start small, but it probably will not break the bank. Okay, we have just a couple of minutes left, Aaron, for any questions that have come in.
Excellent. Thank you, Josh. This is some really great stuff. You know, I was thinking about kind of what you were saying with the cost depending on the size of the installation. It relates to one of the questions that was posed to me, which is there any size of company that is too small to take advantage of IoT?
No, there really isn't. One of my clients is a very small machine shop. They have, I think, 7 people and maybe 10 machines. And they are gathering data from their machines. And they are porting it to the cloud, and they're looking at it. And primarily the data is around the tolerances of the things that they're manufacturing. But there's an example of a little tiny company that's using IoT, and they really have to, because they claim that they can machine needles, for instance, to a millionth of an inch. And when you make that kind of a claim, you better be able to prove it, and you better be able to keep your process under control.
Excellent, excellent. So a somewhat related question was, typically what type of manufacturers are the ones who are currently using Internet of Things? And the second part of their question was, what type of manufacturers haven't started using IoT and they're really missing an opportunity?
It's hard to generalize. In general, the bigger companies, the more sophisticated companies, they're out ahead of the pack, and that's usually the case. The smaller companies are farther behind. The machine tool, if you look at it by industry, the machine tool industry is ahead of the others. Medical manufacturing, medical device manufacturing is pretty far ahead. The industry that's probably the farthest ahead is aerospace. The aerospace companies are hogs for data. They will not take your word for anything about the process. You have to be able to prove it. And the only way to prove it is with data. And there's good reason for that. I mean, you don't want planes falling out of the sky. So they forced the entire industry to get in line. The defense industry is also out in front for the same reasons. The small and medium-sized businesses, they're behind in general. A lot of the kind of custom craft industries aren't doing this at all, and perhaps it's not appropriate for them at all. You should think in terms of your strategy for your business. If your strategy is one of, let's say, very high quality, very high process control, very tight specifications, this will be of more interest to you than, let's say, a furniture shop making custom furniture, where they can tell by look and feel whether the thing is made properly or not. So it depends.
Great. Thank you very much for letting us know that. So one other question was regarding, and I think it's actually more of a question for me. You had talked about the need to have team members who understand statistics. So it's not just a bunch of numbers. It's actually statistics that inform action. And the question was, does Polaris MEP offer basic classes for workers to understand statistics? So Polaris MEP has a partnership with Phoenix Partnership. And one of the things that they do is that they will work with employers who need to kind of create that skill within the manufacturing facility and seek out funds for incumbent worker training. And so that incumbent worker training funds can help reduce the cost, and then we would come in with a partner who would help the team learn statistics at the very kind of action-oriented statistics, not deep dive like they're getting an MBA, but rather how much do they need to know so they can see the trends, spot the trends, and act on the trends. So great question there. Thank you.
I've actually used Phoenix in a prior life when I was running a company in Rhode Island. We sent 3 people to one of their courses, and it was terrific.
Excellent. Excellent. So I think that wraps it up for us. And Josh, you're getting a couple of kudos in the chats, and I want to add mine as well. Thank you so much for this practical knowledge. And thank you, attendees, for your great questions. As Josh mentioned, we will be sending out an email that will have the slide deck from this presentation. And in a week or so, we'll send you out a link to where the webinar itself, the recording, will live online. Josh, thank you so much for helping us see how the industrial Internet of Things can be less about hype and more about helping our Rhode Island manufacturers reach their goals. And if anybody is looking for help beyond this or with this, please reach out to Polaris MEP. You've got my contact information, and we will connect you to those resources, including Josh, that will help you grow and compete. Thank you, and have a wonderful day.